Hey everyone, here we are all ready to go and we are going to graph one full cycle, fully detailed above and beyond, of the following equation or function. It is y equals -2 secant of 4/5 x plus pi over 3 minus 6. So we've seen examples like this a bit. We saw something like this when we discussed the cosecant example I asked you to try on your own. We also talked about it during the introductory lesson for graphing sine, where the b value might be distributed to the entire parentheses with your x minus h or theta minus h, whatever's in there. And the one I gave you for cosecant was pretty easy because the number that you had to factor out, your b value, was 4. And it was pretty obvious how to take out that 4. I chose to do in the guided example this time because I don't want you to try it by yourself the first time, but I chose to do something a little bit messier this time where we're going to have to factor out 4/5 to have it in the form that we like, which is y equals a trig b x minus h close plus k. Could you do it the other way? Option 2, yes. Am I going to go over that right now? No. If you want to do it that way, you can go back and watch that way. I think this is important. It also helps you get ready for integration in calculus when you are doing something known as an antiderivative, when you may not have the right coefficient where you need it, and sometimes it's not that convenient to get numbers where you want them. So you really need to understand how it works to factor something out even when it's inconvenient. So let's get going. Ready? First thing I want to do is I'm going to recognize the fact that I need to factor that 4/5 kind of out in front of a parenthesis. So there's going to be an extra set over here. Y equals -2 secant. 4/5 is going to have to go out there, right? Then this will no longer have a 4/5 on it, right? It's going to be out here, not here. But if I take a 4/5 out of this, I have to take a 4/5 out of pi over 3, which is kind of awkward. You're used to taking out a number or an expression that is fairly obvious. In this case, it's not really obvious, right? So what is going on here? Well, as I pointed out in the video for the cosecant on your own example, when you distribute something, let's distribute, D for distribute. We're going to distribute that to x minus h. If I distribute something, what's really happening is you're dividing the outside by that thing, and then you are multiplying inside by that thing. When we say we're going to multiply inside by that letter D, well, then what happens to the one on the outside, right? You get rid of it with division. So you're multiplying the numerator by doing it inside by the letter D, and you're dividing or multiplying the denominator by the letter D. That gives us 1, which is our multiplicative inverse, that changes the appearance of the example, and it doesn't change its value, okay? Then this goes away, and then each of these will be multiplied by whatever that thing D on the outside was. How do we take it out now, right? So if you have dx minus hd, and I need to factor that out, okay? Same idea. If I want this to be out front, I'm going to multiply out front by whatever that thing is, and in the meantime, I'm going to divide inside by whatever that thing is. So it's all about balance, that multiplicative identity. But what if the d wasn't just d? What if it was d over t? D over t, my initials, right? Well, now I have to multiply out front by d over t. That means I'm technically dividing by d over t, and it's like, oh no, fraction city, ew, right? Nobody wants to do that. Well, dividing by d over t is the same as multiplying by, right here, t over d, and multiply by t over d. That should clean up nicely. T over d, d over t, adios. You'll see this happen with the real numbers in a minute. Adios, adios. and we'd have d over t out front and x minus h left inside. If this all seems crazy, just hold on to your butts. We're going to do it and you'll be okay. Ready? Let's look. I have this. I'm just going to kind of do it on the side. I have 4 over 5 x plus pi, which is really a 1 pi over 3. I want that 4/5. That's my b value. That one I know. That is not your h. This is not left pi over 3. I promise. Promise. Okay. I want that outside. So I'm going to multiply outside by that. That's technically what you're doing. If you just want to say to yourself, I'm in the next step, I'm going to write it out front. Crazy lady, that's what I'm going to do. Stop talking this nonsense. That's fine. I'm just showing you why it works and what's really happening, and you do what you got to do. So I'm going to multiply outside by that, and then inside, technically, you would be dividing by 4/5, but ew, I'm not going to write that. That's terrible. So what am I really doing? Well, I'm multiplying then by 5/4. Multiplying by 5/4. 4/5 and 5/4, well, everyone has someone to reduce with, and if not, you're not doing it correctly, you messed up. Like this should be cleaning up so you only have an x. And then here, always check if you could reduce anything from the top with the bottom. In this case, we cannot, so we're only left with the 5 pi over 12. How do you know if you did it correctly? Try to distribute 4/5 and see if you get back what you originally had in the problem. Okay? And then this whole package gets its own parentheses placed right after secant. So here I have my 4/5 plus 5 pi over 12 and minus 6. That really wasn't so bad, I promise. Again, if you liked option 2, you can do that. Just go back and look it up if you don't remember how. And like I said, I like this because I see that there's the connection with antiderivatives and calculus, so I think it's important. Anyhow, let's go ahead and get some stuff on our paper. So minus 6 is my k value, so I'm going to go ahead and put a dashed line there. And 2 is the, that amplitude of my cosine, underlying cosine. So what is going to happen here? Well, negative 6 will be my sinusoidal axis. 2 means I'm going to have negative 8 involved. I'm going to have negative 4 involved. But you want to remember that you're going to have that U shape going down. So don't put the dotted line so low. This is why we do our little cheap method here. You put your dotted line in the middle of your space that you have to graph. Right in the middle, okay? We're greedy with it, and we use our notebook our way. That right there is y equals negative 6, as we said, horizontal lines, or y equals something. Then I'm going to care about negative 8 as a y value. I'm going to care about negative 4 as a y value, but you want to leave a little room in both directions because you need to see that little scoop U shape going up. You need to give yourself some space for that. Now, if these are all negative, well, then my x-axis, for once, I don't do this all the time, is above. I don't like giving us something like, oh, let's move down and have some of it above and below. It gets so messy, and you try to label and awful, Sir, can I help you? These are my dog's pajamas. They have rubber ducks on them. Do you want to do math? He wants to go down. Okay. He wants to go UT, SIDE. So let's finish this so I can take care of my little muffin bear over there. Okay, now labeling x-axis. There we go. We have an idea where that is. We need our 5 tick marks. So we put 1 on each end. Let's stick 1 in the middle and then 1 in the middle of each of those spots right there. We're doing great. What else? We can put the dots for the cosine wave that would go along with this. So it's negative. So we're going to draw a negative cosine wave. Positive cosine wave. Positive cosine, right? Negative cosine. Looks like that. So I'm going to have that little Darth Vader look. So My spacing's not great, right? It's a little, little wonky. Drawing it dashed. This part's concave down, looking like a frown. This part over here, concave up, looking like a cup, right? And remember, oh boy, we gotta go fast. We're getting whimper noises. It keeps going indefinitely. Here, I started lying. We need to draw our vertical asymptotes everywhere cosine would have a 0. Hey bud, we're gonna go out in a minute, okay? Can I just finish this graph, dude? No? I don't think so. Remember, they share the extreme values. Extreme values. The highs and the lows, that's when they're sticking in together. Okay? We could even get this drawing going. I know this little piece is going to be awkward, so remember when you draw it on your own to be careful. You really want to go up and get as close to that asymptote as you can. There you go. So we've taken care of a few different things. We took care of the negative. We took care of the 2. Hey, buddy, can you come here? Come here. What's this? I'm so mean. Bad mom. Bad dog mom. Come here. What do I got for you? Do I have something here? Can you come here? My first tick mark, my H, which I was using the pink highlighter on for some examples. I don't remember specifically which. It's just showing where this H occurs. So that's over there. Orange was that number. The yellow kind of constituted the negative, the secant, and that negative cosine aspect helped us out. And what do we got to do? Just label our x-axis and figure out where the y-axis is. Same process. So what are we going to do? Period equals 2 pi over 4/5. Similar to what we did a minute ago. Dividing by 4/5. Oof, blurry city. 2 pi divided by 4/5 is the same as 2 pi times 5/4. Think smarter, not harder. Do not make that 10 pi over 4. We reduce 2 and 4. We get 1 and 2. 5 pi over 2 is the period. Period is 5 pi over 2. I don't want the period. I want to find the quarter period. So a quarter of that is 1/4 of 5 pi over 2. Again, can we reduce? This time no, but we get 5 pi over 8 for my quarter period. Squishy, squashy, all the way at the bottom of my paper there. That is the quarter period right there. Salmon color for us right there, right? Then our first tick mark, I think I highlighted it pink, but I didn't label it here, is negative 5 pi over 12. What's the least common denominator? They have a common numerator. That doesn't tell us anything. But negative 5 pi over 12 plus 5 pi over 8 needs a common denominator. How do we deal with that? Well, I would like to point out a couple things. Sidebar, negative 5 pi over 12. Well, that's really the same as negative 5 pi over prime factorization of 12. 2 times 6, which is 2 times 3. And we're going to add 5 pi over 8 to this. Oh, I didn't need to write it there. 5 pi over 8 to this. But what's 5 pi over 8? Really, when you break down the denominator, we need to know what is making up that denominator. 2, 2, and 2. They both have 2 2's. They just need what the other one's missing. This needs another 2 on top and bottom. This needs another 3 on top and bottom. I'm going over this because a lot of people have been asking me to go over it on the side anyway, okay? Negative 10 pi over, who dat? What's that? It's 24. This plus 15 pi over 24. So again, that's H and that's Q. So 5 pi, negative 5 pi over 24, we're going to use 15 pi over 24. So that, oops. So I didn't leave room this time, silly me. So what was it? Negative 10 pi over 24. That's a 10. Oh man, I'm really pushing my luck right here, huh? That's a 1, 0, no, so ugly. Oh man, my dog is upset. He's gonna make sad noise. Come here, bud. Come here. I know. We're going. We're gonna go for a nice walk. And that's a 4. -5 pi over 12. I apologize. And the quarter, we're adding. I just didn't want to clutter this up, you know. Quarter will equal, well, 15 pi over 24. -10 plus 15 is 5 pi over 24. Plus 15 is 20 pi over 24. Plus 15 is 35 pi over 24. Plus 15 is 50 pi over 24. And something that we shouldn't forget in this example, of course, I almost always forget, is the y-axis. So here I had -10 pi over 24 and 5 pi over 24. So my y-axis is, if that's -5, that's 0, you know. So my y-axis is somewheres over there. Looks pretty good, right? -6, -8, -4. So here I have some -4 to get labeled, -6 getting labeled, and -8. Whenever I have negative numbers on the y-axis, I try to always put them on the left so the negative doesn't look like the tick mark on the axis, if that makes any sense. And right there, I'll label my y. And right there, I'll label my y-axis. That's actually pretty good scale also. That would be about -2, you know, so not so bad actually. And that's the end of this example. So for the on your own example that I would like for all of you to give a good shot, give it a good try, we have this right over here. Y equals -3 secant of, don't worry, I factored out the b value for you already, 4 times the quantity, x minus, double nice because minus makes it easier, 5 pi over 7, close, close, minus 9. You're going to graph one beautiful cycle and then find that domain and range, all right? So good luck, wishing you all the best. If you feel pretty good about this, you understand, then give the video a thumbs up. You think like, I followed the guided example, I'm pretty confident that I will get the example I have to do on my own. Thumbs up, great. If you aren't feeling so hot about it and you're like, I don't know if I'm gonna make it to the end of that guy right over there, the one on my own, put a thumbs down. That tells me we gotta work on this more and boost that confidence. You should be feeling better about yourself. So there should be some cards in the video over here, okay? So here I will put a card for how to graph secant, the parent function, the introduction, and here I'm gonna put the card for the domain and range of the previous example that you just, for the example that you just saw. So have a great day and see you next time.